Hi guys, today we'll be looking at how to identify the core voltage of a contactor. And then for the sake of today's video, we'll be taking contactors from Schneider Electric. So straightforward, to get the core voltage of a contactor, they are normally written at the base of these contactors. So you can see this one, 220 volt AC, 5060 frequency or 5060 Hertz frequency. This one is 110 volts AC voltage, 50 or 60 Hertz frequency. And then with the DC contactors, the core voltages are written here 24 volt DC. The contactor operates in such a manner that when the coil of the contactor gets energized, the contacts change states. 1 and 2 changes states. As it stands now, 1 and 2 are normally open, 3 and 4 are normally open, 5 and 6 are normally open. And then with the auxiliary contacts to 13, 14, they are normally open. 21, 22, they are normally closed. So when the core gets energized, 13, 14 becomes normally closed, and then 21, 22 becomes normally open. 1 and 2 becomes normally closed. 3 and 4 becomes normally closed, and then 5 and 6 becomes normally closed. They are the main lines. So I'll try and energize this contactor and then let's see. But before that, I'll have to test with a meter so that we know the state of the contactor. To do that, you take your meter, switch it on, select your ohms reading. We'll be using the beep sound. Make sure your probe is inserted in the ohm column. Test your probe. So you are not supposed to get any beeping in the normally open sections, and then we are supposed to get a beep sound in the normally closed section. We have only one normally closed section. That's 21, 22 contact. We are supposed to get a beep sound. For the rest, we are not supposed to get any beep sound. You can manually test your contactor by pressing this side, and then there will be a continuity. So you can manually test by pressing, but it's not advisable to do that because of the high voltages. So this is a manual press. I'll try and energize the coil so that we'll test and see. So to energize the coil, this is a 24 volt DC contactor. The positive side of the voltage, 24 volts, comes to A1. And then the negative side comes to A2. So you take note of the contactor. When the current passes through it, the state will change. So the state have changed because current has passed through the windings of the coil. To get it back to its default state, you would have to take out the current from the windings of the coil. So the current has been taken out of the windings of the coil. So I'll put the 24 volts back in so that we'll run the test on the contactor. So the state has changed. And then, like I said, when the coil gets energized, line 1 and 2 is supposed to give you a perfect continuity. line 3 and 4 supposed to give you continuity, and then line 5 and 6 supposed to give you a continuity. The base. Small issues. So that's it for the line 5 and 6. And then to the auxiliary contacts, 1314 is normally open, but when the coil gets energized, it becomes normally closed. 2122 is normally closed, but when the coil gets energized, it becomes normally open. So no beeping sound here. And then there's the voltage across the coils, A1, A2. A1 and then A2. So you can see 25 volts, 26 volts. It's a 24 volt DC contactor. So this is how to test functionality of a contactor.